Hello and welcome! We're going to break down one of the most fundamental ideas in JavaScript today, how it stores and manages information. We'll look at the tools you get for free, and then we'll dive into the modern, best ways to keep your data safe. All right, let's get right into it.
So, you ever play a game and it remembers your high score? Or a website greets you by name? How in the world does it remember that stuff? It might seem like magic, but really, it's at the core of how pretty much all software works.
Well, the short answer is variables. But before we get into making our own, we got to talk about the powerful toolkit that JavaScript just gives you right out of the box. Think of it like you're moving into a brand new kitchen.
And you open the door and find it's already stocked with all these amazing appliances. You don't have to build your own calculator or your own calendar from scratch, right? They're already there, just waiting for you. And that's exactly what JavaScript's built-in objects are like.
Here are a few of the most useful ones. So, you've got console, which is kind of like the window into your code's kitchen. It lets you see what's happening inside. Math is your super-powered calculator, ready for anything. And date, it handles all the messy, tricky parts of time zones and calendars for you. They're just sitting there, ready to go, no setup required.
And check out how easy this is. If you need a random number, you don't write some complicated formula. Nope, you just ask the math object for one. One line of code, and it just works. It's simple, powerful, and super efficient.
Okay, so we've got our built-in appliances, but what about our own stuff? Our own ingredients and data? We need somewhere to put all that. This is where we go from using what's already there to creating our own containers to hold our information.
And that's all a variable is. It's just a named container. It's a label you slap on a piece of data so you can find it and use it again later. You know, it's like your digital Tupperware for storing values.
Now, to make these containers in JavaScript, we use a few special keywords. For a long time, var was the only game in town, but it had some weird quirks that could lead to some really nasty bugs. So today, we've got two much better, much more predictable options, let and const, and we're going to focus on those.
You know, when you're organizing your kitchen, you choose the right container, right? You're not going to store soup in a paper bag. The same exact logic applies here. Choosing between let and const is all about signaling what you plan to do with that piece of data.
So you use let when you absolutely expect a value to get updated later. Think about a person's age or a player's score in a game. These things change. With let, you can create a variable like age and then give it a new value later on, no problem at all. It's meant to be flexible.
But on the other hand, you've got const. This is for constants, values that you want to lock in and never change. Think about the value of pi, or someone's date of birth. If you try to change a const, JavaScript will actually stop you in your tracks with an error. And that's a good thing. It's a safety feature to stop you from making mistakes.
But this leads to a super common point of confusion. We just said const values can't be changed, but then you might see some code out there where it kind of looks like they are. So what's the deal? What's really going on?
Okay, here's the secret. Const locks the container itself, but not what's inside the container. So imagine you have a special Tupperware box that's permanently glued to the shelf. You can't swap out the box, but you can for sure open the lid and add more food to it. Here, we're just adding the number 4 to our array. The container, the array itself, is still the same one.
And this shows the other side of that coin. Here, we're not just adding something to the array, we're trying to throw the original array away completely and stick a brand new one in its place. Because we used const, JavaScript says no way and throws an error. That variable is locked to its original container, period. All right, it's time for the main event. Let's put these three keywords side by side. Getting the difference between these is, I'm not kidding, one of the most important things for writing clean, modern JavaScript. This is where it all comes together.
Now this table really nails the differences. And at first row, scope is everything. Let and const are what we call block scoped. It means a variable made inside curly braces, like in an if statement, only exists inside those braces. It's like a secret that's only known in one room. The second you leave that room, it's gone. Var, though, can sometimes leak out of those rooms, which can cause really weird bugs. This predictability is exactly why let and const are the standard now. They're just so much safer.
If you only remember one thing from all of this, please let it be this right here. This is the golden rule. Start every single variable with const. It makes your code way safer and easier to understand. Then, if you realize, oh wait, this value actually does need to change, you can go back and consciously change it to let. Okay, enough theory. Let's actually put this into practice. It's time to see what you've learned with a quick little code challenge.
Take a good look at the code coming up on the next slide. Read through it, think about the rules for let and const, and try to figure out exactly what it's going to print to the screen.
So here's the code. We have a constant called name, we have a let variable called score, we add 5 to the score, and then we log both of them. So, what do you think the final output is going to be?
Go on, pause for a second. Seriously, give it a shot. Write down what you think the answer is. Trust me, there's no better way to make something stick in your brain than to test yourself on it.
All right, the answer is anont 15. The name is a const, so it never changes. It stays anont. But the score was made with let, so we were totally allowed to add 5 to it, bumping it from 10 up to 15. Simple as that. Hope that's what you got.
And so as we wrap this up, I'll just leave you with this one question to keep in the back of your mind every time you sit down to write code. What's that number one rule we talked about? The one for making your code safer, more predictable, and just better? It's all about choosing your default container wisely.